G'day everyone, this is Mark at Turner Laser Systems, and today we're going to do a tutorial on Turner Laser Systems software talking about how to create a recipe. If you haven't already watched the general introduction to Turner Laser Systems software, please watch that video as we go through the general interface. Today we're going to be talking specifically about how to structure a recipe, how to write one, how to get started, some of the basic features of the software such as creating notes, creating variables, as well as adding in objects that you can use for laser processing and how to generally set them up. Alright, so let's get started. So here we have the main screen when you load up Turner Laser Systems software. And we're going to start off with creating a recipe. So first thing you'll see is that we have a brand new recipe that's opened here. If you want to open up a new recipe, you can click on the new tab and open up another one. We can see on the screen here right now we have an empty recipe. So it's completely brand new. And we can start populating it. So the first thing that I like to do is come to this recipe flow region and click on the More button and scroll down to Note. And I feel Notes a highly underutilized feature of this software, and it's very useful for documenting your recipes and providing instructions to users who may want to read the recipe, edit the recipe, or maybe even use the recipe. So it's a great place to come in here, and the first thing I like to do is give it a title, for example, how to create a recipe tutorial. And typically it's good to write who has written the recipe, so you know within your team who to talk to if you have some questions about it. And maybe you could put your email address here or your contact information if you'd like to do that. And then just a general description. This is, in this case, this is a basic recipe used to demonstrate the features of TLS software and how to structure a recipe. Okay, so once we got that in place, you'll notice here on the left-hand side that it says Enter Note here. If you compile this, you'll see that it will update this information. You can also click on this to extend this if you want to see some of the more information on here. Alright, so once we created one note, that gives you a nice intro. I also like to use notes not just for a sort of a title block, but also to section out a recipe. And what I mean by sections is typically a really well-written recipe will have defined sections. And typically I like to have at the start my variables, things like my process variables, so I see them right at the start. What are the key variables that I'm going to be using in this recipe, things like power and speed and all the important variables that you'll be caring about in your recipe. And after that I like to put calculations, and then perhaps some alignment features, and finally the laser processing itself, and then I'd usually end with some log files. So let's add these sections now, and you could do this by clicking on More and going to Notes, and then you can also quickly create more notes by just clicking on it. You can go Copy or Control C, and then you could go Paste or Control V. I'll just Control V a few more, and let's create some sections. So I like to just put it in caps lock or and give it a certain title. So maybe here process variables. Sometimes I'll separate process variables from geometrical variables depending on how long the recipe is. We can do some calculations. Let's see, we can do, if there was an alignment section, we could do alignment. Today we won't do alignment for simplicity. We could do laser process, and let's add a final one. Let's do a log. Alright, so let's compile that, and so now you can see we have all these sections. And the nice thing about doing this at the start is it allows you to think about what your recipe is going to look like and think about the structure of the recipe. In software programming, this is this type of start of the programming can sometimes be thought of pseudocoding or just kind of like sketching out the outline of your software program. And since there is a lot of flexibility and a lot of programming functionality within our software, it's a really nice way to get started and then put your objects inside here. So let's start off with process variables. So let's click on the title, since any objects that we're going to add go underneath the title. So if I click here, it'll go into calculations. If I click here, it'll go into log. So let's click on process variables, and then let's add some variables. Let's add, say, 3 variables, and a very common one that we do is power. Let's call it variable P. Let's give it a certain value. Now for this laser that we're using, power is a voltage measured from 0 volts to 10 volts. Depending on what laser you have installed and how we set it up in the software, it could be a percentage, it could be in watts, it could be in voltage. So have a look at the manual for your specific laser. And then also make sure you create a description. There's nothing worse than seeing a variable and it's got some sort of abstract letter like P, or maybe it's P1, P2 or something like that, and there's no definition for it, and it becomes very hard for another user to understand. So we could call this laser power used in the cutting process, and we could also add the units here. 0 volts corresponds to 0% and 10 volts corresponds to 100% power. And we've got a little typo over here. Let's fix that. Alright, so we've defined the power. What else do we want to define? Usually speeds. Speed's a good one. I like to use lowercase or uppercase v. Let's give it a value of 10 millimeters per second. So speed, and then again add the units, millimeters per second, of the cutting process. If you have multiple processes, maybe you're cutting a circle and cutting a square, you might want to define that in here and say speed of the square cutting process or speed of the circle cutting process. And you could label those v square and v circle, for example, so it's very intuitive. Let's also create one that's going to need some calculation work. So let's create one capital D, and let's make this 10, and say diameter of the circle to be cut, and forgot the units, millimeters. And you know what, maybe this is in, yeah, let's put that in millimeters. And so we've got 3 process variables, that should be enough. And let's go to calculations. So before we jump into calculations, I'm actually going to create the circle so we can see some of the parameters that we'll need to create. So I'm going to click on laser process, since this is the circle is a laser process. And I'm going to choose this origin here and just arbitrarily drag a circle. And so you'll see that we've created a circle at the 0, 0 position within our working space. The center is centered on 0, 0. And for now, I'm not going to change the focus height. I'm going to keep this a simple recipe. And you can see that's asking for the radius. So right now we have the diameter. So one thing that we could do is we could say, okay, well, we know that the radius is half the diameter, so we could do that. Or what we could do is we could reference another variable. So let's do that. Let's reference variable r and create that variable. So if we try to compile this recipe right now, it says, hang on, there is no such thing as r. So that becomes a problem. So let's go into calculations and let's create a new variable. Let's call it variable r, and we'll call r as d divided by 2 in the equation. So note that you can call a variable inside the values, and you can do this both inside objects, but I think it's really good practice to do this inside a variable. And why it's good practice is that you could say convert, for example, diameter units into radius for the circle to be cut. And one of the reasons why I like this is that when you compile it later on, you can see very intuitively here that you're converting the diameter into radius, and you can see what that value is. And so if you took, say, a screenshot of this recipe, you could just have a quick glance at your variables and your calculations, and you can see, okay, this is the parameters that I used, and it's a great way to document this, as well as using log files to document these parameters too. And the other thing you could do is, when it comes to the logging, you could log both your process variables, but you can also log all of these variables as well in your calculations, and that can be very useful. The starting angle, let's just choose 0 degrees, and then let's come to marking. So we need to tell it how we're going to be marking. We're going to do a let's run this recipe laser mark. We might have another recipe and we might call it laser cut. And we're going to use galvo scanners. In this particular case, we have both galvo scanners and stages that we could use for this process. And let's set the power. So you can see already that within this recipe, the output power that was set to P, because it was a previous recipe that I'd saved. If it was sort of a default recipe, it would have been nothing here. It would have been 0 volts. In this particular case, it's set to P. So this is going to make sure that the laser is running at a power of P, which we've defined in our process variables. And it's going to mark at a speed V, which again, the default here would have been 1 millimeter per second. So you're going to have to change that to V. We can do that here. We can change the jump speed to something suitable and change the power. And let's actually create a new marking parameter. And let's call it laser cut. And I like to use a different color sometimes for cutting. Let's choose red. That seems to be a common one in a lot of laser cutting machines. So we've got one repeat, which means it's going to do this cut as a single pass with the galvo scanners. It's going to set it to, now I've put 5 volts here. I'm going to reference P, our variable, and we've referenced V. And we don't need to reference D, but we've referenced R in the shape. So in this case, we've referenced the 3 variables that we'd like to use. So we can compile this now, and there's our circle. If you wanted to add a alignment command, you could come in here, you could go to alignment, and this is where if you had a camera, you would add a camera. Right now, we're running this in a demo mode, so there is no camera to run on here, but this is where you choose a camera. You would select your patterns, pattern 1, 2, or 3, depending how many patterns you have. And then if you would like, you could have it to transform your parts and align it for you automatically with this command, or you could choose none, and instead you could take out the results and do the mathematics yourself if you prefer to do it that way. I usually like to click the transform and have the software automatically do the mathematics for me in terms of transforming its x, y, and theta of the part. So you can have this alignment in here. Let's skip this one for now since we don't have a camera on the system. And then let's go to log. Log would be really useful, particularly if you're running this recipe many times and you have different process parameters and you want to save them all and then look at different times of the day what your parameters were. So let's go to export data, which is used for logging, and it will save this into a text file. You can put the text file name here. You can append the data or overwrite the data, and then you can add what you would like to export. So in this case, we can go to variable, and we can we can choose actually, before we do that, I would typically like to add some text. So we could choose some text, and we might want to go some recipe name on here. Let's put, actually, you know what, I like to start off with the date time, and we could use whichever date time stamp is most convenient. Let's choose this one here where it comes down to hours, minutes, seconds. I think this format should be fine. And then I like to put some text on there, and let's say power is equal to the space, and then I'd like to add a variable, and then we can just reference variable P. And then we might want to also do a new line, and then add some more text, and then we might want to put speed is equal to, and you can also add the units to make it more intuitive. And let's also create the variable for that and put V in there, and then add a new line to enter it. Maybe V isn't very intuitive. Maybe someone who's wants this log file is in quality control and they want this in watts. So let's say, for example, we knew we wanted to do this in watts. Let's go down to our recipe and let's create a new variable. Let's put P down here, and let's create a new process variable, and let's call it power. And let's say the power was, let's say it was a 100-watt laser, such that 5 volts equated to 50 watts. So then if we wanted a power and say this is the cutting power in watts of the laser, where 50 watts corresponds to 5 volts and 100 watts corresponds to 100 watts, then we can come to the calculation here, and we could just say P is going to equal to that ratio. So in this case, P is just going to equal power divided by 10. And we might want to put on here 0 volts corresponds to 0 watts, and 10 volts corresponds to 100 watts of power. Okay, so now that we've done that, we've defined power in watts, we've defined the P variable, which is power divided by 10, and in our object, note that we are marking at power P because our software in this particular case needs to know the power in volts. That's the units that it wants. In our exporting, let's go back to here and let's do power in watts because that's probably more intuitive for a log file. And then in the variable, we'll use variable power instead of variable P because that was the variable that references 50 watts. And then finally, you could create an output file here, so we could just output this to this training folder, and we might want to also save this recipe, how to create a recipe. And finally, we'll want to hit the connect to hardware. In this case, we're running in demo mode, so everything's working in a virtual space. And we'll want to run this recipe. You can see the laser's turned on. It's marking our object or cutting our object, and we're complete. So I hope this recipe tutorial was very useful. And the main things to remember here are to structure your recipe, to give it defined sections, to put variables and your process variable sections, do calculations below. You would then do alignment, and alignment could be two-dimensional alignment with a vision camera as we had here. We didn't go through today, but we'll go through a different tutorial how to also align the focus or autofocus your system using either ZMap feature, or there are other features such as fine focus, which we could use as well. You could also use the transformation for doing alignment if you have a third-party vision system. And then we added in our laser process objects. We just had one circle in this case, but you may have many objects, including CAD files and other text and barcodes, and then logging them towards the end. I hope this was useful. Not to say that this is the only way you can structure a recipe, but there are many different ways you can structure a recipe, and generally breaking it down is a great way to approach it. I hope this was useful, and thank you for listening.